In this video, we're going to have a look at how to determine the equation of a given straight line. Remember that the equation of any function represents the relationship between the x and the y value of each and every coordinate on that function. The constant values indicate the transformations that the function underwent. When you are asked to determine the equation of a function, it is those constant values that you need to determine. So in the case of a straight line, you need to determine m and c. We've already seen that gradient means the change in y divided by the change in x values. This formula can be shortened to change in y over change in x, or you can even choose to use the formula y2 minus y1 over x2 minus x1, which determines that change between two coordinates. We also know that c indicates the y-intercept. To determine these two values, you will need to use the information given on the specific sketch. Let's go and have a look at some examples. Determine the equation of each of the following straight lines in the form y is equal to mx plus c. In the first example, you can see that the y-intercept coordinate is given, and we can immediately say that the c value is minus 4. Now we still need to determine the value of m, the gradient, and to do that, we were given a second coordinate. To calculate the gradient, you can now choose whether you read from the graph or use the formula. I'm going to show both methods. When reading from the graph, you are going to take the two coordinates and move from the one to the other, determining the change in y, or vertical change, and the change in x, or horizontal change. For the change in y, we are going to start on the y value of minus 4 and move upwards to a y value of 0, which is a change of 4 units. For the horizontal change, we are going to start at an x value of 0 and move to an x value of 2, which is a change of 2 units. Therefore, the gradient of this line is 2. You could also choose to substitute into the formula. The formula is simply a formal way to also determine the change in x and y. Using the formula, you are going to substitute by saying that you were given two coordinates with an x2 and y2, and your first coordinate would be x1 and y1. It doesn't matter which coordinate you choose as coordinate 1 and which as coordinate 2. Substituting, my y2 value chosen was 0 minus y1, which is minus 4. Take note that there's a minus in the formula, and then the y value is minus 4. In the denominator, we have x2, which is 2, minus x1 of 0. And when I now simplify, I also get 4 over 2, which gives me the ratio of 2. So the final equation for this straight line is y is equal to 2x minus 4. In example 2, we are once again immediately given the y-intercept, so we can put that into the equation. This time, the second coordinate given is not the x-intercept, but the point 4 minus 1. To determine the m value, I'm once again going to have a look at the change in y over the change in x. And as I've mentioned, you can choose which point you see as the first coordinate and the second coordinate. I'm going to choose to start at point 0,3 and move down to the coordinate 4 minus 1. So my vertical translation will be from 3 down to minus 1. And that is a difference of 4, but because it's downwards, I have to add the minus. Next, the horizontal change will be from a value of 0 to 4, which is a positive difference of 4 units. Simplified, this will give me a gradient of minus 1. And now we have the final equation. This will be y is equal to minus 1x plus 3. If you're unsure about the moving around, you can always choose to once again use the formula. So here I have two coordinates, x1 and y1, and x2 and y2. So substituting, I will start with y2, which is minus 1, and then minus y1 of 3, divided by x2, which is 4, minus x1, which is 0. This will give me minus 4 over 4, which once again gives me the gradient of minus 1. In example 3, the y-intercept is not given. That is why I'm going to start by determining the gradient, the m value, because we were given two coordinates, and with that I can determine the change in y over the change in x. I'm going to choose to start at the bottom coordinate, and for my vertical change move up from 3 to 7, which is a positive difference of 4. Then for my change in x, I'm moving from minus 1 to 1, which is a difference of 2 units. Always ensure that you are also adding the correct symbol. Here we worked upwards, which is positive, and to the right is also positive. This means the gradient is 2, and at the moment my equation looks like this. Next up, we need to determine the c value, which means we now have only one variable to solve. Even though x and y are also variables in the equation, we can, just for the moment, substitute them with actual values. I can do this because every single coordinate on this line represents a specific x and y value in the equation. Therefore, I can choose which coordinate I want to use to, for the moment, substitute into the equation. I'm going to choose to use 1 and 7, which means I'm going to substitute the y value with 7, and I'm going to substitute the x value with 1. Now I can solve c. This means I will have 7 minus 2, and my c value or y-intercept is equal to 5. So the final equation for this straight line will be y is equal to 2x plus 5. Remember that you can always check that your answer makes sense according to the sketch. In our case, the gradient of 2 indicates that it will be an increasing line, and that is exactly what we were given. And the y-intercept of 5 also fits with our graph because we can see that this is a positive y-intercept. If you find something that does not fit with your graph, you can go back to your calculations and check whether you made a sign mistake.